In this example, we're going to look at prime and composite numbers. So we've already defined them, but now we're given numbers. We're not asked to verify that they're prime. We want to determine whether the numbers are prime or composite. So notice in the directions, it says, if it is composite, show at least one factor pair of the number besides one in itself. Once you find a factor pair besides one in itself, you've proven that the number is composite. If it is prime, you need to show that you tested all of the prime numbers less than the square of the number and that none of them divide into your number. Okay, so let's start with 27. Okay, and looking back at our prime number table to see the largest number we have to check. Okay, 27 is between 25 and 49, so we only have to check prime numbers less than or equal to 5. So we need to see if it's divisible by 2, 3, or 5. Okay, so 27 divided by 2. Okay, and here let's write the remainders. So 27 divided by 2, well, it goes in 13 times. Now let's see what the remainder is. 13 times 2 is 26, so the remainder is 1. So since there's a remainder, 27 is not divisible by 2. Now let's divide 27 by 3. And 27 divided by 3 is 9. So that means that 27 has a factor pair, namely 27 equals 3 times 9. And since this isn't 1 times the number, we have now shown that that means that 29 is composite. Okay, so once you find a factor pair, you're a little bit happy because you don't even have to check all the way up to 5. Okay, you find a factor pair, it's composite, you're done. Okay, let's look at the next one. So 91, let's see how high we have to check. 91 is less than 121 and more than 49, so we're going to need to check up to 7, which means we have to check 2, 3, 5, and 7. Okay. And looking at this number, you may think at first glance, this number looks kind of prime. Okay, and the reason I'm saying this is because it's odd. Okay, I can't think of two numbers that we multiply right in the multiplication tables that equal 91. Okay, but you can't just go by that. You have to officially check 2, 3, 5, and 7. It may be divisible by one of these numbers, and you have to be certain. So 91 divided by 2. Okay, so let's practice writing with the remainders. 91 divided by 2 is 45. With a remainder. Now remember, the remainder isn't 5 because we're dividing by 2. We couldn't even have a remainder of 5. To find the remainder, we multiply 45 by 2. We get 90, and we started with 91, so that means it has a remainder of 1. Let's try dividing 91 by 3. So 91 divided by 3, it goes in 30 with some left over. Now let's see what that remainder is. Multiply 30 times 3 and we get 90. So that means the difference between 90 and 91 is 1. So this also has a remainder of 1. So we haven't found a factor pair yet. Okay, 91 divided by 5. Well, 91 divided by 5 is 18.2. Okay, note the remainder is not 2. Well, it may be, but no, it's not. Okay, to find the remainder, we multiply 18 times 5. We see that that's 90, so again, the remainder is 1. Now we have to check one more number. Is 91 divisible by 7? And 91 divided by 7 is, look, it is. It is exactly 13. Okay, so we had to go all the way to the largest prime number we had to check, but now we see 91 equals 7 times 13. So it has a factor besides 1 in itself, so 91 is composite. So again, make sure you check all the factors and don't just go by the looks of it. Okay, 119, let's see how high we have to check. It's less than 121, so good news, we only have to check up to 7 again. So we're going to check 2, 3, 5, and 7. Okay, and in this one, let's not write out all the division. We'll just list them here and look for remainders on the calculator. So 119, we know it's not divisible by 2 because it's not even. Okay, and there's a remainder, so 2 doesn't work. Let's check 3. Is 119 divisible by 3? Remainder, so no, it is not. Okay. Now we know it's not divisible by 5 because it doesn't end in a 0 or a 5, but we can still check it. Notice there's a decimal, so that means there's a remainder, so it's not divisible by 5. And lastly, we'll check 7. And it is 7 times 17. So 119 equals 7 times 17. So this number is also composite. So notice that all of our results were composite here. We didn't know whether they were prime or composite to begin with. Okay, some of them look like they might be prime based on being odd numbers and not seeing any obvious factors that we're familiar with, but when it boiled down to it, they were all composite. The way we verify that is we check all the prime numbers less than the largest number we have to check until we find a factor pair. Once you find a factor pair, you can state that it's composite and you're done.